Hello everyone. In this video, I'm going to demonstrate an interactive Shiny application built in R that helps us understand polynomial regression in a visual and intuitive way. Polynomial regression is an extension of simple linear regression where we allow the relationship between the predictor and the response variable to be nonlinear. Instead of fitting a straight line, we fit polynomial curves that can capture more complex patterns in the data. Although the idea is mathematically straightforward, understanding how model complexity affects performance is often not intuitive, especially for beginners. This is the main motivation behind building this application. In most traditional learning settings, concepts such as an underfitting, overfitting, and model flexibility are explained using formulas and static plots. However, these concepts become much clearer when we can interact with the model and observe its behavior dynamically. This app is designed exactly for that purpose. Now, let me briefly explain the interface. On the left panel, we have a slider that allows us to control the degree of polynomial model. By adjusting these values, we can smoothly move from a very simple model to a highly complex one. We also display the true underlying equation that was used to generate the data, which helps us understand the data generating process. On the right panel, we can see the visualization. The black points represent the observed data. The blue dashed line shows the true function that generated the data. And this red curve represents the polynomial model that is being learned based on the selected degree. Now let's explore how the model behaves as we change the complexity. When the polynomial degree is very low, the model is too simple. Here we can see the model. The model is too simple and cannot capture the underlying nonlinear pattern in the data. This is a classic cause of underfitting, where the model has high bias and fails to represent the true structure. As we gradually increase the degree, the model becomes more flexible and starts to better capture the underlying relationship between X and Y. At an appropriate level of complexity, we achieve a good balance between bias and variance, and the fitted curve closely follows the true function. However, if we continue increasing the degree further, the model becomes overly flexible. Instead of learning the true pattern, it starts fitting the noise in the data. This leads to overfitting, where the model performs well on training data but loses generalization ability. So through this simple interaction, we can clearly observe the bias-variance trade-off, which is one of the most fundamental ideas in the machine learning. In addition to the visualization, this app also displays the estimated polynomial. Here you can see the estimated polynomial equation and the training error measured using root mean squared error. This helps us connect the visual intuition with numerical performance and understand how model complexity affects the error. Overall, the Shiny app application provides a simple but powerful way to build intuitions about the polynomial regression, model flexibility, and overfitting behavior. It is particularly useful for teaching and learning machine learning concepts in an interactive and engaging manner. Thank you for watching.